Okay, so we are looking at the CCEA AS Pure Mathematics from May 2019. So let's take a look at question 1. So we have 3 equations, 3 unknowns. So lots of arguments for making the x's the same, z the same, but I'm going to go with the y's. So first of all, I will number them 1, 2, and 3. And if I'm going to go for then 2 times number 2, so 2 times 2 gives me 4x minus 2y plus 8z is 34, and then number 1 is x plus 2y plus 3z equals 9. We can see here we have a minus 2y and a plus 2y, so I'm going to add those two equations, and that gives me then 5x plus 11z, the y's disappear, equals 43. I'm going to call that equation 4. Not too much really we need to do then, so 2 plus 3 is going to work. So if we do 2 added to 3, we will then get 5x plus 3z equals 19, and I can call that then equation 5. So luckily the x's are the same here, so we're just going to subtract them. Might be neater to write them out again, but we're okay as we are. So 4 take away 5 is then going to give me 8z equals 24, which gives me z equals 3. I'm going to then substitute my z equals 3 into equation 5. So I will get then 5x plus 9 is 19. 5x is 10, and x is 2. I'll probably just sub these into equation 1. So that means we're going to have 2 plus 2y plus 9. Hopefully you're happy with where that's come from. Equals 9. That gives me 2y is minus 2. And that gives me y is minus 1. So just writing my answers out then at the end, I have x equal to 2, y equals minus 1, and z equals 3. On the question 1b, we have vector OA is 4i minus j, and vector OB is 6i plus 2j. Find the magnitude of the vector AB. So you don't need to do this, but it just kind of shows the diagram. So I have a point O here, and this is my point position vector A, this is position vector B. How do I get from A to B? I would go minus A plus B. So that's going to be OB take away vector OA. So 6i plus 2j take away 4i minus j gives me then 6i take away 4i is going to be 2i. 2j minus minus j is then plus 3j. So that then is my vector AB. I want then the modulus of AB, or magnitude, sorry. It'll be 2 squared plus 3 squared, and that's 4 plus 9, which is 13. So So my magnitude then is going to be root 13, and it's fine then just to leave your answer like that. The angle AB makes with the positive x axis. So again, if I draw a quick diagram, AB is of course 2i plus 3j. So that would be 2. That would be 3. There's my positive x-axis. So I'm looking for this angle here. So using SOHCAHTOA, that's going to be O. That's going to be A. So I'm going to use tan. Call that angle theta. It's going to be 3 over 2. So theta then is tan minus 1. 3 over 2. And theta then comes out to be 56.3 degrees. The three significant figures. Question 2. Figure 1 below shows a sketch of the graph of the curve given by the equation y equals f of x. And we have this point A has coordinates 0, 1. Write down the coordinates of the point A under the following transformations. You don't necessarily need to draw a wee sketch of the graph out, but I find it makes it a wee bit clearer. So y equals f of x plus 1. What does that do to the graph? It moves everything up 1 or 1 further away then from the x-axis. So my graph then, again, there's a very rough sketch here, would look more like that. If everything's moved up, that's 2. So my point A is then going to be 0, 2. Y equals f of x minus 3. So this one's sort of the other way around, if that makes sense. So the x minus 3 moves everything this way, 3. So again, exactly the same graph, exactly the same shape. How everything now is moved 3 across this way. So it was here, it's now here. That's a 3 and that's a 1. So you can see none of that. So everything, it's the same graph, same shape, everything moved across 3 here. This is the point 3, this is the point 1. So 3, 1. Y equals f of minus x. So f of minus x, that reflects everything in the y axis. So the graph now becomes something like this, and sure enough that point then hasn't changed, so it's still the point then 0, 1. F of x has an asymptote given by the equation y equals 0. Write down the equation of the asymptote of the curve under the transformation y plus 2 equals f of x. So y plus 2 equals f of x is the same as y is equal to f of x minus 2. So what does that do to the graph? It would move everything down 2. So my graph originally went like that. If everything's moved down 2, we have something like that. The asymptote was here. The asymptote is now going to be here, where that's minus 2. So it's going to be y equals minus 2. Okay, question 3 then, we have some logs questions. So log the base 2 of a equals 3. State the value of a. So what does this mean? This means 2 to the power of 3 equals a. That's all a log means. So 2 to the power of 3 equals a. It's a very straightforward one then. A equals 8. Hence solve the equation log the base 2 equals 3. Okay, so we're going to use our laws of logs here. So log to the base 2 of x x over x minus 1 equals 8. And you see it's pretty much the same format as the question up above. Only the a has been replaced then by this. So we know, sorry, I've made a mistake there. It should be a 3 obviously. I'm getting ahead of myself. So that means 2 to the power of 3. I suppose we're not really using the information x over x minus 1, and so we know then that x over x minus 1 equals 8 from up above. Multiplying through by our bottom line, we're going to get x equals 8x minus 8. Rearranging would give us 7x equals 8, and x then equals 8 over 7. On then to part B, find the exact solution of the equation 3e to the 2x minus 4 equals 0. So a little bit of rearranging to start with. So 3e to the 2x equals 4. E to the 2x equals 4 over 3. We now need to take logs of both sides. That will make the natural logs of both sides, of course. So that'll make the e disappear. So we get 2x equals ln 4 over 3. And then x equals a half ln 4 over 3. And because they've asked for the exact solution, that's the answer then that's required. Quite often they have exact in bold, but they don't in this case. But that's the answer. If you put that in your calculator, you lose a mark. Question 4. Find the range of values of k for which the equation x squared plus kx plus 16 equals 0. So this is a discriminant question. So if it has no real roots, then b squared minus 4ac must be less than 0. So our b then is k, so it's k squared minus 4 upon 1 upon 16 is less than 0. K squared minus 64 is less than 0. And you can take a couple of different approaches here. You just need to be careful that you don't just give an answer then of 8. But what I would suggest doing maybe is to kind of plot the graph. So if you have y equals k squared minus 64, it's just a quick sketch of the graph. We'll kind of show you what's going on. So it's going to be y equals, that's the difference of two squares, so it's k minus 8 upon k plus 8. So the graph will look a little bit like this. Negative 8 and 8. We know it's a positive k squared. So we would have something like that. And we're trying to find then where this is less than 0. So if it's less than 0, then it's going to be below then this k-axis here, normally the x-axis. So where is this line below this line? That's anywhere in between minus 8 and 8. So k must be in between minus 8 and 8. Okay, so find the center and area of the circle given by the equation this. So we need to complete the square here. So this is going to be, for the x, it's going to be x minus 2. And that generates, so I take half of the minus 4 there. Hopefully that makes sense. So it's x minus 2 all squared. That gives me then a 4 that I don't need. So I'm going to subtract my 4 plus y plus 3. That gives me a 9 I don't need. Minus 9 minus 3 equals 0. Rearranging this then, x minus 2 all squared plus y plus 3 all squared equals 16. Therefore, my center is going to be 2 minus 3, and my radius then is going to be 4. area of a circle then is pi r squared. So it's going to be then the r squared is going to be 4 squared 16. So my answer then is going to be 16 pi, and that then is units squared. Hopefully that makes sense. I don't know if I did this bit too quickly here, but hopefully you can see kind of completing the square and rearranging this, we end up with this. Okay, so an integration question here. So we need to integrate this here between k and 1. Given that it's equal to 20 over 3, find then the value of k. So let's get this into a form that we're going to integrate first of all. So between 10 and 1 over 2x to the power of a half dx. If I integrate that, add 1 to the power, divide with a new power, okay, and 1. And then if we tidy this up very slightly, so I would multiply top and bottom of this then by 2. So it's going to give me 4x to the power of 3 over 2 all over 2 between k and 1. And we can now then kind of set this equal to the 28 over 3 and see if we can solve it. So if I substitute k in here, I get 4k to the 3 over 2 over 2, and then put 1 in here. Sorry, I've made a mistake there, haven't I? That should be a 3. Knew something wasn't quite right. Over 3, and then take away whenever I substitute in 1. So 1 to the power of 3 over 2 is just 1, so that's 4 over 3 minus 4 over 3 is equal to 28 over 3. Hopefully you can follow what I did there. If I multiply through everything by 3, that makes life a lot easier. 4k 3 over 2 minus 4 is 28. 4k to the 3 over 2 is 32. K to the 3 over 2 is 8. And again, I mean, you can do logs here if you wish, but hopefully you can just kind of see. So some number, whenever you cube it and you take the square root, it's going to give you 8. So if you want to go backwards, you could square it to get 64 and then take the cube root to get 4. But my answer then is going to be k equals 4. One of those ones I'd probably want to check after I've done it. So let's check if I substitute 4 in here. 4, take the square root, gives me 2, and then cube it is 8. So that's going to be correct. On to question 5b, and let's solve this equation here. So the way we're going to solve this equation is we need to change it so it's all the same trig ratio. So we need to change this into a sign. Hopefully you know that cos squared plus sine squared equals 1. So I can rewrite this as 2 upon 1 minus sine squared theta equals 1 minus sine theta, multiplying out the bracket and taking everything then over. I'm going to take everything over actually to the right hand side probably, so we'll go 2 minus 2 sine squared theta is 1 minus sine theta. Everything over here then 2 sine squared theta minus sine theta minus 1 equals 0. Some people like then to let sine theta equal a different letter. So let sine theta equal, let's go for t. So we then have 2t squared minus t minus 1 equals 0. Makes it a little bit easier then to factorize. Now, some people factorize these in different ways, especially with it's not a 1 there, but I'll just go straight in and hopefully you'll be happy enough. So it's going to be 2t plus 1 and then t minus 1, and putting the sine theta back in again. Again, you don't need to use the t thing if you don't want. If you want to go just from there to there, that's fine. This is then going to give me sine theta is minus a half, and here sine theta is 1. Generally go cast diagram here, so we would take the basic angle, and so I would go then sine theta is a half, and theta then is 30 degrees. Putting this in on the cast diagram, CAST 0, 90, 180, 270, 360, and my basic angle here is 30. I want, however, where sine is negative, so my answers then are going to be here and here, of course between 0 and 360. So I want this angle here, so that would be 180 plus 30, so that's going to be 210. And I want this angle here, and that then would be 330 degrees. Sine theta is a tricky one. You just need to be careful. What happens with the cast diagram is it's just effectively looking at the graph, and I think the graph's a much better way. Hopefully you're familiar with the graph of sine theta between 0 and 360, but it effectively looks like this here, where this is 1, this is minus 1. So where is sine theta 1? That's just going to be here, and that's where it's 90 degrees. If you go on the cast diagram here, it's fine, you kind of get it there, but some people get confused and then put it down here as well, and that's not the case for sine, so just be careful with that if that's the way you're going about it. Anyway, we've got 3 answers here, and so I would write them then at the end. So theta is 90 degrees, 210 degrees, 330 degrees. Okay, question 6. An open tin in the shape of a cylinder is shown in figure 2 below. The open tin has base radius r and height h. The total surface area of the tin is 300 pi centimeters squared. To express h in terms of r. So if it's an open tin, we have 2 bits to it. If you fold out the curved surface area bit, we have this bit here, and because it's an open tin, then we have the disk at the bottom. So the area of the disk is of course then pi r squared, and hopefully you've seen something like this before, but the area of this bit, that is h. This here is of course 2 pi r, because that's the distance of the circumference, so that then is going to be 2 pi r h. This plus this equals 300 pi, so we have 2 pi r h plus pi r squared is 300 pi. Dividing through by pi, we'll get 2rh plus r squared is 300. And it says express h in terms of r, so we need to get the h bit on its own. Nice and straightforward. Take away the r squared and divide by 2r then. So it's going to be 2rh equals 300. Take away r squared, and that means h is 300. Take away r squared over 2r. Hence show that the volume of the tin can be expressed as this. So what's our volume of the tin? Let's look back at our tin. It's going to be the area times the height, so pi r squared h. So volume equals pi r squared h. Volume is pi r squared upon, and the h that we just worked out was 300 minus r squared all over 2r. So if I guess multiply this through, we'll see what we get. So V equals 300 pi r squared minus pi r to the power of 4 all over 2r. I'll do an extra wee line here. You don't necessarily need to do this line in, but hopefully you'll see where it's coming from. Pi r squared over 2r minus pi r to the power of 4 over 2r. This r is going to cancel with this r here. The 2 is going to go here, so we have 150 pi r. Here the 2 doesn't cancel, but one of the r's does, and we end up with that. So our final line, which is what they've given us in the question, is 150 pi r, take away pi r cubed over 2. Next part then, the volume of the tin is V was 150 pi r cubed over 2. Using calculus, find the value of r and h for which the volume of the tin is a maximum. Please note that if you didn't get the previous parts, you can still have access to the 7 marks here. So even though some people in the previous parts kind of forget this or don't manage to get this wee bit, it doesn't mean you can't get these marks here. So don't stop the question just after not getting parts 1 and 2. You can still continue on then to get this. So we need to differentiate this. I don't like this in this form. I kind of like the number out the front, so just rewrite it before differentiate. 150 pi r minus pi over 2 r cubed. I know there's very little difference there, but it's just nicer. So differentiating, then we're going to get dv by dr. Sometimes it takes a wee while to work out which is on the top, which is on the bottom there, but hopefully we're okay. If I differentiate this with respect to r, it just makes the r disappear. Hope that's okay. Say you have a 5x and you differentiate with respect to x, you just get 5. So we just get the 150 pi here. And then we are going to take 1 away from the power and multiply by the old power here. So we're multiplying by the 3. So 3 pi over 2 r squared. We're trying to find a maximum, so we're going to put this equal to 0. dv by dr equals 0. So it means 150 pi minus 3 pi over 2 r squared equals 0. Rearranging, 3 pi over 2 r squared is 150 pi. I would cancel the pi's there. If you times by 2, you'll get 300 and then divide by 3, so you just get then an r squared equals 100. Hopefully you're okay with that. And it means then our radius is going to be 10. We need then to find the h. So h is 300 minus r squared all over 2r. So 300 take away 100 all over 20. 300 take away 100 is 200 divided by 20 is of course 10. So h actually is 10 then as well. You can't get full marks on this. You actually prove that it is a maximum. So we need to differentiate this again. So d2v by dr squared. The 150 pi is just a number. It's just going to disappear. And here then we're going to take 1 away from the power and multiply by the old power. So it's just going to make this 2 disappear. So we're going to have then 3 pi r. Whenever I substitute the number 10 into this, I get a negative number. Therefore, it's a maximum. Okay, question 7, we have to solve this cubic equation. So we're going to use a factor theorem, try some factors of 10 to substitute in here. So we would try 1 and minus 1, we would try 2 and minus 2, we would try 5 and minus 5, and 10 and minus 10. So let's try 1. So f of 1 is equal to 2, take away 8, plus 3, plus 10. You work that out, that's not equal to 0, so that's no good this. I would try then minus 1, minus 2, minus 8, minus 3, plus 10. No good this either, so they're not going to work. So f of 2, 2 cubed is 8 times 2 is 16. 2 squared is 4 times 8, so minus 32. Plus 6 plus 10. And sure enough, that does equal 0. So how does that help us? That then means that x minus 2 is a factor. So we want to set up our long division and divide through. So x minus 2, 2x cubed minus 8x squared plus 3x plus 10, x into 2x cubed goes 2x squared times, multiplying through then, we get 2x cubed minus 2 times this minus 4x squared. I always need to be careful here. Minus 8x squared minus minus 4, so that gives me then a minus 4x squared, and bring down then my 3x. So x into this goes then minus 4x times minus 4x times this minus 4x squared plus 8x. That gives a minus 5x, and bring down my 10. Into that then goes minus 5. Minus 5 times that is minus 5x plus 10, and sure enough we get a 0. So that means my original question now becomes x minus 2 and then 2x squared minus 4x minus 5 equals 0. This obviously gives us a solution that x equals 2, and this one here I guess we could try and factorize. So if you do 2 times minus 5, you'll get minus 10. So two numbers will multiply to give minus 10, and the same two add to give minus 4 isn't going to work for us, unfortunately. So what we're going to do, we're going to have to use the formula. So you could do that or you complete the square, but with the 2x squared, I think it's nearly easier to use the formula. So we're going to go for x equals, so if I go for my a is 2, my b is minus 4, and my c is minus 5. So x is minus b, so it's a minus minus 4, so it's 4 plus or minus the square root of 16 minus 4 upon 2 upon minus 5 all over 2a, which is 4. X is 4 plus or minus the square root of, so it's 16. 4 times 5 times 2, that gives me a 40, so 16 plus 40 is a 56 and over 4. So how can I tidy this up? I'm going to use my surds, so it's going to be 4 plus or minus, you got outside, the square root of 56 is the same as the square root of 4 times the square root of 14. 14 is not going to go down any further really, so it's going to be 2 root 14 plus or minus 2 root 14 all over 4. I'm tidying up slightly further, so x is Move it down a bit. 2 plus or minus root 14 all over 2. So those are those two solutions there. Or x equals 2. That's as far really as I can go. You can do that one out separately if you wish. 1 plus root 14 over 2, 1 minus root 14 over 2 is fine as well. Okay, then question 8. The points A and B have coordinates 2a, a squared, a plus 1a respectively, and a isn't equal to 0. A straight line perpendicular to AB passing through the point A cuts the x-axis at point P. Find in terms of A the coordinates of the point P. So I'm going to do a quick diagram here. Now it's not that relevant, it's just so you can see what's going on. So here's our axes. Let's go for, I don't know, maybe A and B being here. So there's my line AB, and they say then that this other one is perpendicular. I didn't want to have it so close actually to the axis, but that's okay. So that's perpendicular, and it goes through then the point P. So in terms of A, we need to try and find then the point P. So we're going to try and find it kind of effectively in terms of A, the equation of this line here. So because we have this point and this point, we can get the gradient here. If we get the gradient here, then we know the negative reciprocal is going to be the gradient here. So let's try and set this up. So our gradient of AB is going to be y2 minus y1 all over x2 minus x1. So my y2 then is going to be a, take away a squared all over a plus 1 minus 2a. So let's try and tidy this up a bit. The top bit I suppose factorizes. Bottom bit a, take away 2a, so it's just 1 minus a. So hopefully you see what's going to happen there. This cancels with this, so the gradient then of the line AB is just equal to a. Therefore the perpendicular gradient is minus 1 over a. So if we substitute that into, let's try and find the equation of this line here. So if we go for y equals mx plus c, we should be able to work out our c term, because we know then the point. So it's the point A and the gradient then of this line are the two things we know. So the y coordinate is a squared, the x coordinate is 2a. So we would have then a squared equals minus 1 over a upon 2a plus c. That cancels with that, so you have minus 2. So a squared equals minus 2 plus c. That means c equals a squared plus 2. So our equation of the line then is y equals minus x over a, because that's my gradient. If you remember, it's a minus 1 over a times x, plus a squared plus 2. So nearly there. It has asked us to find the coordinates of this point P. So we have the equation of this line, and we know at P then that whenever it cuts, sorry, it's cutting the x-axis. Oh goodness. So this here is my point P. Luckily that hasn't messed up too much. So it's cutting the x-axis then at that point. That's okay. And so at that point then we know that y is going to be equal to 0. So we know it cuts x-axis when y equals 0. So that means 0 equals x over a plus a squared plus 2. X over a equals, so that's a minus x squared minus xa, and then that turns positive there, a squared plus 2, and that means x, multiplying through then both sides by a, I'm going to get x equals a cubed plus 2a. So the x coordinate is that. What's the y coordinate? And of course the y coordinate is just going to be 0. Therefore p is a cubed plus 2a 0. Okay, part 2 then. The midpoint of the line AB has equal x and y coordinates. Find the possible values of a in their simplest surd form. So we need the midpoint then of the line AB. If we remember, a has the coordinates 2a, a squared, and b has our coordinates a plus 1a. If we then find our midpoint, this plus this, so 2a plus a plus 1, so 3a plus 1 over 2, and then a squared plus a over 2. If the x and y coordinates are equal to each other, then we set this equal to this. So we have then 3a plus 1 over 2 equals a squared plus a over 2. Quite obvious, I think, that we want to multiply by 2. So we get 3a plus 1 equals a squared plus a. Rearranging this, I would get then a squared, take this over to this side, minus 2a minus 1 equals 0. A couple of different ways really of doing this one. You can complete the square reasonably quickly, or you could use a formula. I'm just going to use a formula as ever. So a, b and c, as quite confusing as that sounds, is going to be 1 minus 2 and minus 1. So my a then is going to be equal to 2 plus or minus the square root of 4 plus 4 all over 2a, which is 2. So a is then 2 plus or minus root 8 over 2. Root 8, I hope people know then, is root 4 root 2. So that's just going to be 2 root 2. So a is 2 plus or minus 2 root 2 over 2. These 2's effectively cancel, and so it's going to be 1 plus or minus root 2, or my two possible answers then for A. Question 9 then, this shows diagram of a circle, centre O. AB is the diameter, that's okay. S lies in the circumference, so that's okay. D is the foot of the perpendicular from B and OS, that's okay. The acute angle BOS is theta. OA equals OB. OA equals OB, they're both radiuses, and so they're equal to R, so that's fine. So that wee bit that's going to be R. And then it says that OD is X, so that's X. By applying the cosine rule to the triangle AOD, show that AD squared equals this. So our cosine rule is going to be for this triangle here, so it's going to be quite tough then to work out, and it's this here. So this here is the one opposite this angle here, and if this is theta, then this is going to be 180 minus theta. So what is our cosine rule? Our cosine rule is a squared equals b squared plus c squared minus 2bc cos A. And we're going to take, don't confuse this A with this A. Effectively, this is going to be our A, and so the one over on this side is going to be our AD. So it's going to be AD squared is equal to, I need to go back up in here, then R squared plus X squared minus 2 Rx cos, and remember our angle then is 180 minus theta. So this is a tough one. Cos of 180 minus theta is just the same as minus cos theta. I hope we can kind of see where that's going to come from, but you can actually change this here to a minus cos theta. You can try for any angle you want, and it will work out. So cos of 180 minus 40. So cos of 140 is the same then as the minus cos of 40. So our next line, and this is quite a tough line to see, but my AD squared equals R squared plus X squared plus 2RX cos theta. So it's a tough one. Next one, we're looking to try and get this, and you'll see there's no x's in it, so we need some way then of getting rid of our x. So if we go back up here, this is x. Again, this is a radius. So if we take this wee right angle triangle out here and take this theta, that's the adjacent, and that's the hypotenuse for this right angle triangle here. So cos theta equals A over H. So cos theta equals X over R. So that means X equals R cos theta. So that means anytime I see an X, I can exchange it then for an R cos theta. So X is R cos theta. Let me get one more line here. That means AD squared equals R squared. So this here then squared is going to be R squared cos squared theta plus 2R cos theta cos theta. So how does that tidy up? Try and set it up like this. Hopefully you can see it in the previous line. That means AD squared equals R squared plus R squared cos squared theta. 2R times R is 2R squared, and then the cos theta times the cos theta gives you that. So AD squared equals R squared, and then these are two like terms, plus 3R squared cos squared theta. And of course then if we take out our R squared, 1 plus 3 cos squared theta. Okay, final part then, when BD bisects OS, so that means cuts it exactly in two. AD is R root K over 2. Find the value of K where K is a positive integer. So let's take a wee look here. What they're saying then is BD bisects this. So if it bisects this, then this is X and this is X. So 2X then equals R. So 2X equals R if whenever BD bisects OS. So how's that any good to us? That gives us that X is R over 2. And from our triangle length OBD, if we set it up again, or you can just kind of go back over here if you want, we know that cos theta then is R over 2 over R. So why does that tidy? This is a half of r and this is r, so that all just cancels and we end up then with a half. So that means cos theta is equal to half. We are told that AT squared equals r squared upon 1 plus 3 cos squared theta. So let's see where this takes us. AD squared equals r squared upon 1 plus 3 upon a half squared. AD squared is equal to r squared. So a half squared is going to give us a quarter, so that then gives us 3/4. 1 plus 3/4 then is going to be 7/4. That means AD is then going to be the square root of r squared. 7/4. So AD is then square root of this is r. Square root of 7/4 is root 7/2, which looks very like what we're looking for here. So we have r root k over 2, and so hopefully you can see then that in this case k must equal 7. And that's the end of our paper.